We were given the exponential equation a raised to the power of b equals c, with a less than 0, c greater than 0, and b is a positive integer. So again, we're given the exponential equation a raised to the power of b equals c, and because a is less than 0, we can say a is negative. C is greater than 0, so we can say c is positive. And b is a positive integer, so b is in the set of positive integers, which would be 1, 2, 3, 4, 5, 6, and so on. To determine what else must be true about b, let's select a negative value for a. Let's say a equals negative 2. Perform substitution into the equation with these values of b and see what we can determine about the value of c. So if a is negative 2, and we use the first value of b, where b equals 1, we'd have negative 2 to the first equals, well, negative 2 to the first means we have one factor of negative 2, which equals negative 2. If we let b equal 2, we'd have negative 2 to the second, which would be negative 2 times negative 2, or positive 4. When b is 3, we'd have negative 2 to the third, which would be negative 2 times negative 2 times negative 2, which is negative 8. When b equals positive 4, we'd have negative 2 to the fourth, which is equal to positive 16. When b equals 5, we'd have negative 2 to the fifth, which equals negative 32. And when b equals 6, we'd have negative 2 to the sixth, which would be equal to positive 64. Now remember, the right side of these equations would be the value of c, but we're told c must be positive. So here, c cannot equal negative 2, which means b cannot equal positive 1. Here we have c equals 4, which is fine because 4 is positive, which means b can be 2. Next we have c equals negative 8, which cannot be true because, again, c must be positive, so b can't be 3. Next we have c equals 16, which is fine because 16 is positive, so b can be 4. Here we have c equals negative 32, which cannot be true, again, because c must be positive, which means b cannot be 5. Looking at the last equation, we have negative 2 raised to the power of 6, which equals 64, and c can be 64 because 64 is positive, which means b can be 6. So now we know that b can be 2, 4, 6, it cannot be 1, 3, 5. So looking at our positive integers here, we know b can't be 1, 3, or 5, but it can be 2, 4, or 6. So from here, hopefully we can recognize that b must also be even, because a negative number raised to an even power is positive. So let's write this out. The value of b must also be even, because a negative number raised to an even power is positive. I hope you found this helpful.